Welcome back to Laravel Podcast Season 4. Today we're talking about object-oriented programming with Alena Holligan, a senior software engineer at Lumen Learning and a former teacher at Treehouse. Stay tuned. All right, welcome back to Laravel Podcast Season 4. I'm your host, Matt Stauffer, and a reminder this season, every single episode is about a specific topic that we think folks should be learning as they're stepping into the Laravel world. These first couple episodes are primarily about stuff that aren't just Laravel specific, but they're things that are really helpful for everybody to know. So last week we did one about Composer, and this week we're going to be talking about object-oriented programming with Alena Holligan. And Alena and I met at Sunshine PHP years ago, thanks Adam Culp. And since then, she's been working with Team Treehouse and then recently moved to a company called Lumen Learning. She lives in Portland. So Alena, could you tell me a little bit about yourself, say hi to the people, and also talk a little bit about your kind of background and what Lumen Learning is and what your job is like day to day?
Sure. Thanks for having me on here, Matt. I appreciate it.
Coming.
So I started out in fine arts, and I always thought programming would be the most boring job ever. I had an uncle that was programmer, and I thought, no way, never. But I got introduced to programming at the Art Institute of Phoenix as another way of design. Like, yeah, you could do some drag and drop stuff, but if you got into programming, you could do more. And instead of it being like a painting where you just hope someone gets something out of it, with programming, it gave me the opportunity to hold their hand a little more and bring them through. And like show them what I wanted to show them. And so I really enjoy the fact that programming is another form of design, and it's creative and it's a puzzle. I love puzzles.
Yeah.
So I really like that about programming. So I started programming 20 years ago, over 20 years ago now. When I started in PHP close to 20 years ago, it was not at all like it is now. And there was no object-oriented programming. And so I started programming what I was doing. And then all of a sudden this object-oriented stuff came out. And I thought, oh, okay, this is great. And I tried to figure it out. But there was a problem that I ran into, was that because we had object-oriented, now all of a sudden we can do all of these things like frameworks. Frameworks were really difficult before object-oriented programming because there was no way to think of code as separate chunks. Instead, it was just this huge procedural base of code. You had to know all of it and have it all in your head, and it had to all kind of go together. Yeah, you could split out files, but you couldn't think of it in chunks. So you couldn't build a chunk of your framework before there was really object-oriented programming. So when it came along, all of a sudden there's all of this new ideas and new ways of going that kind of got mixed up with what object-oriented was and what just other new features and abilities were. And so that, first off, was the big challenge. And then you go to ask questions about object-oriented, and they throw out all these big words like encapsulation and polymorphism, and like they expect you to understand what they're talking about. And you just go way more confused than you were to begin with. And so that was really challenging. And so when I started, it probably took me 2 years. After I had already been programming, it probably took me 2 years to even feel comfortable with, I think I kind of have a grasp on this object-oriented thing. Lorna Jane Mitchell is actually one of my heroes in helping me learn object-oriented. She had some videos out at the time that really helped me understand what was going on. And so once I understood this, I'm like, there's got to be easier ways. Like this isn't that complicated. Like, there has to be better ways for people to learn this. And so that kind of became my passion, was to make this easier for the next person. I don't want it it shouldn't take 2 years for somebody who's already been programming to learn this new thing.
Yeah.
And so that's where I really got focused on. So we moved to Portland about 6 years ago from a small town. So there wasn't anything where I used to live to all of a sudden there is a meetup going on every night of the week. Some tech meetup you can go to every night of the week if you want to. I found out there is a 20 meetup limit to join per day on meetups.
Wow.
So that's your limit, or else they think you're a robot. I easily did that.
You discovered this. Wow.
Yes, I easily did that. Just things I was interested in Portland. So that was great. And I started out with like the Women Who Code group and things like that. They actually started the week I moved to town. The Women Who Code Portland started that same week. And so I got involved with them right away and started teaching object-oriented to new people there in person. And then through Code Oregon, that's really got the word out about Treehouse locally. Lots of people I met in Portland knew of Treehouse and like, it's a great place to work. So when a job came through on the PHP meetup board about Treehouse, I'm like, yes, I had been a student. I had been a student and I was actually going back through Java because Craig Dennis is awesome. And he was a Java teacher at the time. I had done Java before. And I'm like, this should give me some not having gotten my degree in programming. I'm like, I'd like to fill in any cracks. Like, where am I missing stuff? And so I'm like, it would be good to do something else. So let's go through Java. So I had picked Java mostly because of Craig. And so when the job came along, I applied, and like 2 days later, still hadn't heard anything. So I'm like, that's fine. I really want to work there. So I tweeted to Craig and I'm like, hey, Craig, love your courses. I saw there was a PHP opening and I haven't heard anything. And Dave jumped in and is like, I emailed you 3 times. So my big tip, if you're applying to a company, make sure you don't have their emails filtered for some other reason. Because I had been a student, all the emails went in a filter for my Treehouse emails, and I never saw it. But
tip of the episode. There you go.
Yeah. There's my first big tip. Right. Make sure your email is not getting filtered.
Love it.
So I worked there for like 4 years, and like I was really excited about teaching object-oriented. That was my first big thing there. They really didn't have a robust object-oriented training yet there for PHP. And so that was like what I was really excited about. I'm like, I can really reach more people and teach them object-oriented programming. And so I was really, really excited to do that.
And so now you're at Lumen. So I know it's also educational, but it's obviously not the same thing. Could you tell us a little bit about Lumen real quick?
Sure. I actually am back in development at Lumen. And what I'm really excited about there is the fact that I get to work on an old code base and start to refactor that, which is something that I've also been interested in doing. Yeah. And so now I have that opportunity to do that. And so we do alternatives to college textbooks for students. And now with the pandemic and people working from home and trying to do school at home, all of a sudden it's even more important that they can have courseware that is conducive to online learning. So awesome. we provide, I actually work on the math portion, and we have cover most topics, college level topics that we do for. So we provide online textbooks, and we actually have a lot of open source educational resources that we use and that we can contribute to as well in That's that awesome. Realm.
And we'll link both some of your Treehouse courses and also Lumen's website and your Twitter and everything all in the show notes. If anybody's curious about any of that, go check out the show notes and you'll see all these links. So I know that you have done a lot of work with OOP, not just in terms of thinking about it and teaching it, but also trying to make it approachable to folks who are new to it, which is exactly why I got so excited to bring you on, because I was like, I want to make OOP approachable. And I remember when I first, I had been programming for years and been writing PHP for years. And then I tried to start using OOP. I think it was in PHP 5.3 or something like that. And I just couldn't wrap my head around the concepts. And one of my friends who was a Magento programmer had to learn it maybe 6 months ahead of me, because they got into OOP a little bit earlier than I did as a result. And he tried to give me the whole like person is, like all the generic kind of examples, and it didn't click. And it took me several years to click. So I identify so much with that. And I'm hoping that that's less the case for folks today. But let's assume Well, we'll go there in a second. I always start with the first question, which is, if you had to describe this concept, and this particular concept is object-oriented programming, to a 5-year-old, how would you describe it to them?
It's interesting. I have a 6-year-old. 6, 7, and 8
perfect.
now are my kids.
Nice.
And I always think you should be able to describe anything to a child at 5. Like 5 is once they're 5, they really can understand most things.
Totally.
So if you can't describe it, then you don't really understand it. So it's a good question. So if I was going to describe object-oriented programming, it depends on, again, in teaching, how far back do we go into what do they understand? So first, before you can teach what's object-oriented, you'd have to say what's programming. Right. So if we're talking about programming, and let's say we've had a couple conversations on programming, so they have a little bit of an idea about what that is, then what is object-oriented programming? It's this idea that you have the data and the functionality grouped into pieces that you can work with, so that they are individual pieces of code that can work independently, and that you can know something goes in and something comes out. And then you can work on these pieces individually. And that's what really is the power of object-oriented programming, is that you can work on this smaller chunk and use that to build more complex things.
Yeah, I love that. It's so fun because I had, we talked about Git in a previous episode, and I love when I ask a question and the answer is not the classic answer I think I would expect. And like Gemma did that with me with Git. I asked what is Git and expected one thing, and she answered it in a much more nuanced and rich and simpler way. And that's what you just did there. So I love that description. But now let's get a little bit nerdier. Let's say you were talking to an experienced programmer who somehow had missed OOP. And it's not because they were, deciding to use some other type of programming. It's just because they were still writing procedural code until today. How would you teach them? How would you describe OOP to them? Or
well, actually, it starts the same way.
Yep.
I mean, it really, if you can't explain it to a 5-year-old, then you can't explain it to an adult either.
Yeah.
And so that's one of the problems with teaching. And one of the problems I had with learning it is that people either used terms that you expected they already knew, or terms that to make you look good, to make you sound smart. And that's not useful. When you throw out words like abstraction and encapsulation and polymorphism, those are all great OOP concepts, but they don't actually mean anything if you're just new to object-oriented and you're just trying to ask a question. Throwing out those words have no meaning yet because they have I don't understand them. They have no basis in my knowledge. And so throwing out words like that is not helpful. So yes, I would start with the same way. If you're trying, the great thing about object-oriented programming over procedural code is that now we can work in smaller chunks and more people can work together. Whereas procedural code is really useful if you've got a project and you're the only one. You can do procedural code fast and easy. It's a good place to start because there's less complication, but you have to store all of it in your head at once. Right. And so once things become larger or you're working with a larger group of people, all of a sudden procedural becomes much more difficult and you need something else. And that's why object-oriented is more helpful than procedural code when you're looking at either a larger code base or working with multiple people, because object-oriented is this idea that you have the data and the functionality grouped together in these small chunks that you can work on. So I need to know, what do I pass in and what do I get out? And that's all I need to know about it. And someone else can work on that chunk. So if I need to use it, I need to know what goes in and what comes out.
Right. Lots of little black boxes floating around that do all the work, and you give it data and get data out.
Yeah, it's a lot like functions in that way, that you would pass stuff in and you bring stuff out, other than functions only perform manipulations on the data. They don't store the data themselves.
The representation,
Yeah, so they can't store any of the data. So the objects let you store the data with that functionality.
Yeah, that's great. So if we were to kind of go a little bit forward and say everybody, should learn what OOP is. So you've given great kind of a couple sentence descriptions of them. Are there core tenets where it's like the top 3 this or this principle and that principle that you would think of as really definitive of what object-oriented programming is?
I like to start with a lot of my explaining to people what those words are that you'll hear. So understanding terminology is important because you're not going to be able to, like, Google's amazing. You can Google and get all kinds of answers. But if you can't understand the answers, it doesn't do you any good. Totally. So one of the first steps that I really talk about in learning object-oriented is just understanding what those concepts are. They're not hard. What are those terminologies that people are going to throw out there, and what do they mean? So terminology is really important, I think. It's one of the most important things that I feel in teaching people because, like I said, Google's useful, but only if you understand it. And you can't understand it if you don't know the words. So understanding the words that surround object-oriented is important. And then understanding why we have objects. And then something else that I really like about object-oriented, because it ties that into, is is our interfaces. Like, to me, interfaces are a good example of what object-oriented is for. Not that you even need to use interfaces, but they explain a lot of what it is. Because like I was saying, I need to understand what goes in, what do I need to give this, and then what am I going to expect back? And that is what an interface does. It sets up that contract. The interface simply says, this is the type of data you're going to pass in, and this is the type of data you're going to get out. With PHP 7 and continuing to add on in 7, we now have a lot more. We have other choices than just interfaces in being able to make that distinction by typecast, by giving the type hints for what types are coming in and what type you can expect out and all of that stuff. Those are anything that helps you know that, I think, is really useful because, again, to me, the idea of object-oriented programming is the idea that you can work on small chunks and you can all work together to make something bigger and better than you could on your own. And so if I can understand how to work with your piece, that's all I need to know. So it needs to be that interface between your piece of code and my piece of code is what needs to be clear. So however we make that clear, there are several choices, but however we make that clear, that to me is the most important part.
Yeah. I appreciate that. I've also often noticed that OOP is the easiest to describe visually, at least for me. And so trying to have you kind of teach all this stuff over a podcast is definitely tough. So I apologize to you and everyone else, but I think you're doing great so far. So so you've covered some of the more complicated terms, just as examples of things that people say without, fully making sure the other person understands, like polymorphism and encapsulation. But if there were just a couple core concepts, and you said terminology is the first thing to know. What are the first couple things that, in order for OOP in general, and also maybe even just the rest of this conversation to make sense? You mentioned an interface. What other kind of high level concepts are there that somebody should know if they're going to learn OOP? And I'm thinking simple things, like classes and everything like that. So what's on your list of things that just, you got to get these out of the bat before you can even follow anything else? Well,
the first things that we talk about are properties, are the variables that are inside a class in your object. Instead of a variable, it's called a property, essentially. Mm-hmm. And your functions inside a class are called methods. But they're essentially, so the data is your properties, the functionality is your methods. But even within your class, your methods are called function whatever, because that's what they are. They're the function. So that helps you to communicate, is this something that's in a class or not in a class? So if I'm talking about a function outside of a class, it would be a function. A function inside of a class is a method. So that's important to know. Another thing of the very basics that's important to know is understanding this. So that often trips people up. This or some of the ones for static, which are things like static or self or parent with the double colons. Those are all different ways of referencing the object that's created. So you have your class is your blueprint for your object that describes how the object will be created, just like a blueprint from a house, for a house. And then the object itself, which there's each object instance could be called an instance or an object. Those are oftentimes interchanged, but the instance is the individual instance of it. Like Matt is an instance of a human, and I am also an instance of a human. Those are different instances. We're both humans. We've used the same blueprint. We have different things that make us up, but the blueprint is the same. Like how it's put together, we have the same things. So we have our object, we have our instance, and then to work with those inside of those objects. So inside the class, it uses terms like this to refer to itself, just like I would use like I.
Right.
I am something. That's what this does. This is referring to this particular instance of that object. So I think that's one thing that often gets, like, you see this and you're like, whoa, that's weird. Because if you've never done a class, like, or even if you've seen it, you just don't understand what it is. That to me also was like, okay, I've used it even, but I don't really understand what it's doing. And then especially when you get into static methods, which are ones that you can call without actually instantiating an object, you can read directly from that blueprint from that class, and you can say, hey, I don't need to save any state. I don't need to have any data saved. I just want to know if I give you this data, do something with it and spit it out, like format something or whatever. And in there, because we don't have we haven't created I yet. There's no concept of I. Now you have things such as self, static, or parent. And those are all with the double colons. And those are all the things that reference this current working with that class, like the class itself, like this is something here. So I think those are things that really simple concepts that if you don't understand them off the bat, it makes everything else a lot more complicated.
Yeah. Or everything works and then all of a sudden you change something, you don't know what broke because you don't understand the difference between self and static or self and this or whatever. Yeah, totally.
Yeah.
That's very helpful. Do you have any, I know that like even understanding the difference between self and static, my brain takes a second to register which one I want in any given moment. Do you have any tricks you use to remember which one is which? And, and for anybody who's not familiar, self and static both refer essentially to the class that you're working on, but one of them refers to the actual class and one of them refers to basically like which specific class you're working with, even if that self is being called in one of its parents. So if I were to make like a human class and then there was like a programmer subclass of human, and then there was like a teacher subclass of human. And by subclass, meaning like, we haven't talked inheritance at all. Gosh, I'm trying to explain this one thing without actually going to 10 other topics. But yeah, so basically self versus static. Yeah, you're familiar with that challenge more than I am. The self versus static defines whether, when an instance, or not an instance, when a static method is referring to, I guess it could be other things, but referring to the class blueprint, right? Is it referring to human or is it referring to programmer, basically? So it's kind of changing the hierarchy, like how high up in the inheritance chain am I going before I either call this method I'm calling on self or static, or before I get this property that I'm getting on self and static. I know we haven't talked inheritance, so it's totally my fault that I just dug into this thing, but I'm just super curious. Do you have a shortcut that you use for remembering which one's which?
You're not often using static. You really aren't. They're very, very seldom that you're using it. But if there is something particular, like it's not working the way you want it to, those are the types of you look at it. Like just knowing there are two ways and that they might refer to different things and how it works together. But that's once you get into inheritance a little bit more, you'll understand how that works. But really, don't often use static, so you will see self more often. But just knowing that oh, I want to be able to reference this particularly, you probably can. There is probably a way to do it. So if there is something specific that you want to do, there is probably a way to do it. You just have to know the specific way of calling it. And that to me is much more important than even remembering which way is which. Just going, hey, there is another way to do it. This did not pull the data that I expected it to pull. Oh, there is another way. Yes, there is. PHP can do it. You just have to know what that is. So you can find the specifics. You can look it up. There's no stigma. Nobody's keeping score of how many times you look in the manual. Most developers probably have some sort of manual or something, or Google open every day. Like everybody looks up something every day. You don't program in a box. Mm-hmm. So I don't think that's as important to memorize because you won't use it as often. Okay. So I would just say don't worry about trying to get that one stuck right now. Don't worry about getting that one stuck in your head because you're not going to use it that often. But just knowing that it's there and knowing that you can look it up, like the PHP docs are actually really helpful. Yeah,
and anybody who's so. One of the things I try to say in these is we want to make this primarily targeted at people who are new, but make sure that we also are, including little tidbits here and there for people who have been around. So if you've been around for a while and you've struggled with self versus static, what I would tell you is go look up PHP late static binding. And that's actually the thing that was introduced in 5.3. And late static binding is, again, new folks, don't worry about this right now. Nerds, people who've been around for a while, we're all nerds, whatever, learn about late static binding because it was one of the most transformative things that was added to PHP that made modern tooling like we have today available. And it allowed us to give... anyway, yes. Just go learn about late static binding. I'll put a link in the show notes.
Is really when you're going to use static. So if you're going to use that, that's when you're going to use static. That's what it's for.
Yeah, perfect. All right, cool. So the next thing I want to start asking you about is use cases of object-oriented programming. So the first thing I want to say is I would say if you're in Laravel, you're going to use OOP whether you like it or not because frameworks, PHP frameworks, Laravel, and the Symfony components is based on all of our packages, Composer, all these things are based around the ideas of OOP. So obviously, in the Laravel world, almost everything we do is going to be OOP, especially when you're first getting started. But I do want to just ask the high level of question of when do you think it makes the most or the least sense to use OOP? And so far, we've primarily compared procedural and OOP code, but there are other ways of coding. So if you were to think of an instance in which OOP wouldn't make sense, what would you reach for? What are the other options that you would consider?
I actually really am fascinated by functional programming. That's been some of the best conference talks I've ever gone to are on functional programming. And you wouldn't think about PHP as a functional language, and it's not, but a lot of the same concepts that are used in functional programming, they are available to PHP. Yeah. And it really helps understanding those concepts are really useful, especially for OOP, because you can use. It's that idea, really, it helps you understand why you're returning what you return. Is really, when you look at it from a functional perspective, like all of a sudden, why do you return this versus returning versus returning a value? And that is, so there are some things that cross over with object-oriented programming. So if you are doing object-oriented programming, looking into functional programming will really help you understand why object-oriented is doing certain things. And it will actually help you to, I think it was almost easier than object-oriented in a way that to understand concepts. And so then it helped me to apply that to my objects a lot better. So I would highly recommend just more looking into functional programming. Again, you can do a lot of it in PHP, even though PHP isn't designed as a functional language. You can do a lot of functional programming in PHP.
Yeah, I couldn't agree with you more. And especially this being kind of like one of the ones where this particular note is a little bit more to the folks who are listening to this going, okay, Matt, I know what a class is. Ask her some more complicated questions. One note for you guys, that was a fantastic tip. And for new folks, don't worry about this yet. But for those of us who've been writing OOP for a while and get it, I love that point. Your OOP will get so much better when you learn functional programming, not only because you'll bring some functional patterns back in, but your understanding of the motivations and the reason. Like we learn OOP for sure, but we don't always really deeply understand what or why or anything. And when we understand those things, we use it better. We architect better the next time. And learning functional programming definitely helps that. And I've got an idea in my head that could be entirely wrong. So I'm going to just say it. I was going to try and Google it. I'm just going to say it. In my mind, if anyone's like a sci-fi geek or anything, there's an idea called a head canon. And so like, if you think about like the canon being like the thing that is ultimately true about the universe, right? And so in a lot of like Star Wars universes, whatever, you've got the canon, like this is true and this is not true. And when someone says my head canon, what they mean is I've made this up to be true in my head, but I know it's probably not actually something that came out of reality. So one of my head canons about functional programming is that collection pipelines, where you're mapping and reducing all that kind of stuff, is a deeply functional thing. And I could be wrong. And, Alena, you may or may not know if I'm wrong, but someone will tell me on Twitter if I'm wrong, but in my mind, that's a thing. And the idea of moving from, and so that's why like functional programming is one thing, OOP is another thing, and procedural is another thing. Functional and procedural are not the same thing. And if you would imagine, like, how would you iterate over an array and do a whole bunch of things to it? You do it one way by passing array walk into array, this, that, with the other. And it would look different in a collection pipeline. And in my mind, the collection pipeline has always been more functionally. Do you know enough to know that I'm right or wrong, or should we let someone on Twitter tell me if I'm right or wrong?
That is a lot. That is one way that PHP really does use functional programming. That idea of functional programming is that it really is the idea of the pipeline. The functions can be looped together. They can be chained. Functions can be chained for things to happen. Like, yes, that is functional programming. The problem that people run into is the idea that they think that just because I'm using objects means I'm writing object-oriented code. Well, you might be using objects, but it's not really object-oriented code, and that's it's fine. But that's the other thing, is that it's okay. That is fine. Yeah. You can be writing in a very procedural way that uses objects. You can be writing in a very object-oriented way that uses functional programming. That's okay. Being able to use those where it makes sense for you and whatever your project is, that's the important thing. Like, one of my biggest tip for people for programming anything is you want to make it readable and usable. Like, if that made it way too complex, if you can't even keep what you just did in your head, you probably don't want to do it that way, because then it's too complex. So simplifying things, it should make it easier. Object-oriented should make it easier than procedural code. If it makes it more difficult, now caveat there,
difficult for whom?
Difficult at different. Knowing what your understanding is, and if you don't understand objects at all yet, everything is going to be more complicated. But when you're making decisions, you don't have to go all in and be, I'm writing an object-oriented program. You can be writing a procedural program that uses objects. I really like the way Adam Watham talks about testing. His idea that you don't have to jump all into test-driven development. Yeah. Like, you don't have to go all in to make it useful for you. Yeah. Like, start out with making it useful. Is this easier? Did this help? Then use it. If it's making it more complicated and it's not helping, you need to rethink it.
Yeah, I love that. And I think that the core tenet there that I love so much is It's a combination of two of my favorite phrases, which is number one is it depends, and number two is use it if it works, or use it if it's good for you. Like if it's helping you here, use it. If it's not helping you here, don't use it. If you don't know, learn about it. So that's perfect. I love that. So I want to go further in, but I know we've got a lot more left to cover. And so, but I want to ask you one last question here. And if you don't feel comfortable answering it, I'll just delete this question. If you were to explain functional programming to a 5-year-old, how would you explain that?
Functional programming is more like a train, because you chain things together. And it's the idea of declaring where you want to be. Like you're declaring, I want to go from here to there. And it's actually, I think, maybe an easier way for people getting started. And your idea that what's the first thing that you want to do to this? Well, first I need to do this. Well, and then I need to transform it some way. Like I'm taking my program or my idea, and the first thing I need to do is this. Yeah. Or we can go backwards and we can do the same thing, like break it down. Functional is a lot like what you're breaking, how your brain works. Because if I'm going to say, let's write out the instructions for making a peanut butter and jelly sandwich. One of those challenges that they have in first grade or whatever it is, that they say, write this out. Well, if what are we starting with? Again, are we starting with the bread? First, you have to have your ingredients, and then and your tools. You need your ingredients and your tools. And then what's your steps? And those steps are really what functional does. It's like, I did this first thing. So now I still have everything that I did. I have my sandwich at this point. And now I want to, great, you made your sandwich. Now you want to cut off the crust. And now you want to cut it into a fun shape. Well, you need to take your sandwich that you made and then cut off the crust and then put it into a fun shape. It's that stepping through. And I think functional program really talks more to that aspect in how you think about it.
And I love that because we do those things in our code, and the number of times that we build things where an object that we're working with needs to go through steps, or an object transforms into another object that goes through steps. I mean, that's a super common concept. And just a quick note here, again, a little bit more advanced for folks, but if you are taking an individual object and applying modifications for it, that is the number one most useful time to use things that return this, meaning you're building fluid chains. People at Titan always tease me because, especially Daniel Colborn, who is no longer there, but he's still a friend of Titan, because I almost always, if I see something return this in a pull request, I'm gonna delete it, because people don't often know what they're doing when they're returning this. And I think that things are used fluently when they shouldn't be. But when fluent chaining, and again, this is for the more advanced folks who are a little bit newer, just so you know, fluent chaining means on your instance, you can call one method after another, after another, after another. So you'd say, whatever, car or whatever, sandwich, arrow, add bread, arrow, add peanut butter, arrow, add jelly, arrow, put together, whatever. So basically imagine you're kind of like just constantly operating those things. You have to have each method return this, so the arrow of that method can be called on the output of the previous one. And it is most helpful in my mind when you're taking something that is not established. It's not at the state it's going to be eventually. And you're taking a multiple steps. And when you're done, it's now going to be at that established point. It's like data modification or whatever. And so I appreciate you saying that, Alena, because I think that is one of the ways for me that functional programming ties in, is because there's certain programming patterns in OOP that make sense at some times and not other ones. And we can see those parallels and learn from them. So thank you. And I know that I didn't give you prep on that. I was going to ask you that. You did great. So I could talk about that for half an hour, but I know we need to keep going. So let's talk a little bit about what gets people tripped up. What do you think the aspect of OOP is that takes folks the longest to learn, or people are most likely to get caught up on, whether it's about length of time or not?
Terminology.
Yeah.
That to me is really the number one. Yeah, that's the number one thing that gets people tripped up. So while we're here, so we can untrip people, let's talk about those words that are used in object-oriented a little bit, just because I think those are the things that really trip people up. They hear these words and they automatically just put on this, like the wall comes up, and they can't get beyond that because of all this. They don't understand this, and so they can't look beyond it to understand what the other things that are said. So some of the words that we talk about in object-oriented programming, we talked about the class a little bit already, which is your blueprint. But other words that we talk about are things like encapsulation. Mm-hmm. All of the words in object-oriented are not specific to programming. Like, these are not programming concepts. These are world concepts. Like, they're in all kinds of places in the world. So the idea of encapsulation is just like I was saying, an object has your data and your functionality put together. And that's the idea of encapsulation. It encapsulates both the data and the functionality of that data. That's what encapsulation really is. And so then we move on to abstraction. People talk about, well, let's abstract that away. Like, I don't need to know that right now. We'll abstract that. Abstraction. Well, what's the idea of abstraction? The idea of abstraction, again, it's this abstract concept that you talk about, not in programming. What are these abstract concepts? These are things that we talk about without being able to understand. Just like you get really existential about this, but it's those things that we don't have to understand how they work to talk about them. Yeah. Like, and that's the idea with objects. And that's what I've gone back to saying before, you need to know what goes in and what comes out. And that's how we can talk about it, is the idea that what happens in that object, I don't care. I don't care how the function works. I don't need to know how that function works. I just need to know when I pass it this information, I'm going to get out this information. And that's what abstraction means, is the idea that I don't have to understand it. I don't have to understand how a car works, how an engine in a car works to be able to drive the car. Right. Or I don't have to understand how that function works to be able to use it, or that object works. I need to know how to use it, and that's it. So that's the idea of abstraction, is that I don't have to understand the inner workings. I just need to know, what do I get? What do I pass? What do I send to it, and what do I get out?
I love that. So you got more? Give me more.
Yeah, I've got two more real things that I want to get onto. Polymorphism.
That was my next one. So good.
Polymorphism. Again, it's not a programming specific one. Polymorphism is the idea that there is something that we all do, that all these objects do, but they don't have to do it in the same way. So for example, like if you were to speak on an animal, if you were to tell your dog to speak, they're going to bark. If you tell your cat to speak, they're going to meow. A human to speak, they're going to, someone say hello. Well, saying hello in English versus Spanish versus French. It's the same thing, even though if it produces a different result, it's the same type of thing. Yeah. It's still a response. It's saying hello in a different language. Like, that is polymorphism. That idea that it's the same thing in a different way. And that's all polymorphism is. Yeah. And then the last thing is inheritance. And I really like the concept of inheritance, because being a parent, to me, that's very important. Right. The idea of inheritance, think about as a person, whether you have kids or not, we have inherited things from previous generations. We've inherited knowledge. We've inherited good things in the world and bad things in the world that we've inherited from previous generations that we already have. And hopefully we can grab on their knowledge and the tools that they've given us and to build something better. That's the idea. You want to give your children all of the information and tools that you can for them to be successful, but you should not want them to be a copy of you. They should go beyond you. And that's the idea of a child class. We have parent and child class, and it's that same thing, is that they inherit. They can do everything that the parent did, and then they go beyond that. And that is what inheritance is. Like, and I can determine, as when you're creating that parent, you can determine how much things should be changed. Like, this is true. And this is the way I see it, but you may need to make up your own mind on how this is going to work for you. So we can set up what can be overridden in the child and what can be extended upon and what is final. And you have those controls in object-oriented, but the idea is to think about it in a way that you want your child to go beyond. Like you don't want to just change it. Like you don't want to take your parent and just change it because you didn't like the way it worked. Like that's not the idea of it. The idea is to go beyond, is to have all of that functionality, all of those tools and abilities, and move beyond that.
I love that. And that's true both in terms of the ideological, which I really appreciate because I've got young kids too. It's also even true in the practical if you're thinking about DNA. And obviously it's not a perfect parallel because you're not extending to and getting a various mixture of them. But you have some of those same ideas of the things that are expressed in the parent are, expressible, in the children, but then they also end up having some things that are different, in them. So it's not as direct of a thing. So in terms of those listening, listen to more what Alena said than to what I said. But I like it. It's making my brain think because, and again, you're doing this fantastic thing that I love where, again, if I were to say, what is polymorphism or what is inheritance, I would start talking about classes and children. And you didn't do that at all. And I love that. You're talking about the high level ideologies and the high level, the ways that our brains work. And also you're making all the parents in the room choke up a little bit, so that was, thank you for that. That was awesome. So I want to go there so long, but we're going to go so over time. Okay. So I won't do that. I'm glad that later I get to ask you, is there anything else you want to talk about? And where should we learn more about this? Because I need to go on 2 more questions before we get there. Which aspect or tool or piece or whatever, or pattern in OOP do you think is the most often misunderstood or misused?
I would really like to get beyond the fact that people try to use object-oriented concepts to sound smart. Like they don't throw polymorphism out as a way to sound smart. Like explain the concept. Explain what part of polymorphism actually makes sense here. Like what do I need to know about polymorphism, or what piece of polymorphism am I using here? Yeah. And so I would say, for me, especially, one of the things that I found most challenging and what tripped me up the most was not being able to understand the answers. Yeah. So you'd Google something and Google should be great and you should be able to find answers. And there's all kinds of answers and they've all, this is the way, this is exactly how it works. And they have words in there that just confuse you even more than you were to start with. And that I think is really one of the biggest challenges.
I love that. And I think that you've used that reference. And I love that reference because I definitely remember Googling things and seeing 3 sentences worth of stuff. And whether or not I knew all the words, and I frequently didn't, it's obviously implying a context that I don't have. And so I'm like, I know that's English, but it means nothing to me. And I also, of course, love what you're saying here about, not using to sound smart, both because I think we should just be kind to each other. But also I don't think that, so words, the more specific words are, the more potential they have for us to use to communicate them well. I get, teased a lot for using big words, but the big words I use are because that was the word that most communicated the thing I was thinking. And I could have used a simpler word or whatever, but it wouldn't have been as accurate. And so those words have so much power for communication when we use them in ways that further communication. But if we use them in moments or contexts or whatever else where, the purpose is not communication, or even if we're not trying to do it to make ourselves look good, if we're not thoughtful and empathetic to the person we're talking to understand and ensure that they understand what we're saying, we're actually decreasing communication by using that word. And so it's a little bit about reading the room, understand who you're talking to. And if you don't know, ask and make sure that you're using those words in ways that make sense to them. And also don't shame them if they answer, I don't know. And one of the things that we've in hiring at Titan, and I'm sorry, I'll stop going just 1 second. We have one of the biggest things somebody can do at Titan to ensure they don't get a job during the application process is to pretend like they know something and we can tell that they don't know it. Because if you do that, then we can't teach you and we can't work with you because you're gonna hurt us and you're gonna hurt yourself. You're not gonna grow. Some people do it out of arrogance, but most people do it out of not wanting to look dumb when they're interviewing. Like, it's a totally understandable thing. The problem is doing that keeps you from learning the thing. And so developing the practice of saying, you know what, I'm not sure. What does that mean? On the one side is really helpful. And the other side saying, yeah, I really think we should use polymorphism. Does that make sense? Or should I kind of go in a little bit more detail, both as, non-condescending, peaceful, humble things that we can do to just ensure that we're communicating well. Thank you for bringing that up, because that's fantastic.
And I think I really, I'm applauding. I love the use of words where their meaning is clear and that word describes what you're talking about. And that's great. Yes. And so really it's about, are you breaking down this concept to explain it? Or are you using these words because you really can't even go into the details of how that works? Well, I know it's encapsulation, so I'll just use that word. Well, how is encapsulation working here? Well, I don't really know how to explain that to you. So I'm not. And so instead of making yourself feel bad or take that extra time to figure out how to explain it and maybe make you better, or you've shoved off your lack of knowledge to somebody else so they feel bad instead of you. So just be careful that you're not using words in a way to be like, I don't want to get any further into this concept. This is how much I can explain it. So I'm just going to stop here. I'm going to stop with this word instead of going into the word when that actually answers the question.
Yep. All right. Once again, I love this. And let's go. We got 2 more questions, and then I want to ask some learning things. So the first question is, what, if any, piece or tool or anything of object-oriented programming do you think that people should be using more? Is there something where you said, man, I so many see problems pop up that if people were just to use XYZ, they would realize that it's actually solved within this ideology that they're working in? Or is there nothing that really sticks out for you for that?
Well, 2 things. Which kind of build on each other. One, I'm so glad that you already had Jordi on about Composer. I think Composer has been fantastic. That's probably been, to me, one of the biggest tools that object-oriented made possible. That is super helpful. If you don't learn any other tool, you learn Composer. And it's so much more than just package management. And that really brings into namespaces, again, which is another place where people get hung up on, and being able to do auto loading, which is really useful. Those are things, looking to Composer, that they're great. But again, namespacing, it's another concept that, it's too hard or whatever. I don't get it. Or people just assume people know what just namespace it. If you don't understand it, again, it's really easy to not be able to use it right. Again, really, really important things there. Composer is a great place to look at doing that type of thing.
And if you're not familiar with namespaces, they're basically folders for your classes. But the big difference is you're referencing the folder structure when you're referencing those classes. So if you throw it in a different folder, then now the way to reference that class later now has to reference the change in folder. And the good thing about what Alena's saying here is that when you're using like PSR for auto loading and using Composer to auto load it, bringing in your own custom code usually really actually means that in order to change something's namespace, you just A, move it to a different folder, and then B, change the line at the top that says namespace. And there's tons of great tutorials out there for you. But in general, that's how I start. You're laughing. You got into namespacing, and I'm like, I didn't want to get into okay. I will shut up.
No. I love it. And it's another thing, like namespacing. This is another one. Like, okay, think of namespacing. Your application is the island, is the mainland. And for namespacing, and it has it, just, you're always using namespaces, even in PHP, even if you don't think so. There's a global namespace, so you're using the global namespace. You're always using a namespace. So your island, your mainland is your application. Your application is the mainland. To use anything on any island, which are multiple islands around, those are the other people's code that you're pulling in, these packages that you're pulling in. And to use them, you have to do 2 things. First off, you have to have a connection to that island. And then you have to tell it that that's the island to go to. And those are the things to remember in using namespaces, because that's where you have the like use clause or the namespacing. I need to know this code is on which island. So we name it. I'm on this island. And then to use that, first my application has to have a bridge there. And often that's most likely going to be your auto-loading things. But you will also make that bridge by going either specifically saying follow this bridge, or when you're calling it, go across this bridge to get your box, or go across this bridge to get your box. Or you can say at the top, like, set up this bridge. I'm now going to call this bridge A and this bridge B. So use A to get the box, or use B to get the box. You need to have both of those. And if you don't have the bridge already, you can't just say, go get a box, because it doesn't know where to get the box from. And so that's the trick I think people run into with namespacing is, what's this long path, or what's the use at the top? Well, first you have to have that build that bridge first, and then tell it where you want to go, which one to go to. So.
I love it. And obviously this yet another topic we can nerd out on forever, but I will go here and I'll ask, is there anything else before we start wrapping up that you really think that we should have talked about that we didn't get a chance to cover yet?
Be kind to yourself.
Come on.
Be kind to yourself, object-oriented. You don't have to know it all at once, but learning a little bit more, learning as you go, getting better. That's the whole idea of refactoring code. Refactoring to me is something that we always have to do. We are always refactoring ourselves. We're always refactoring our code. As you learn better, do better.
That's so good.
But don't beat yourself up over what you don't know now.
And interestingly, that's both like a life philosophy, which I love and I appreciate you saying it. But even for someone who has been writing object-oriented programming for a long time, I am the worst thing that happens to me with object-oriented programming today is if I get paralyzed by needing to get the object relationships and definitions perfect at the beginning. And so what is most useful to me in OOP today, when I'm especially writing new objects and stuff like that, is just to write something. And then as I start using it, to figure out, wow, there's way too many methods here. This should be extracted. Or these three methods are all passing the same object between them. Maybe they should be extracted and then store that object as a property on the thing, whatever. And so it's, like even in the actual practice of being an experienced programmer writing OOP, there's that same thing. Don't try to get it perfect. Do what you have, refactor it, get your test. So it's that thing fits in a lot of places. So thank you, Alena. All right. So if somebody wants to learn more, what were some good places that they could look to learn about OOP?
You should be able to you can find me on Twitter, Alena Holligan, most places, or Sketchings. I'm Sketchings on GitHub. On my GitHub repo, I have a lot of sample code for beginners. We just did a training with Ed Bernard. I just did a training with Ed Bernard for Midwest PHP conference online, where it was a whole 2 days of beginner tracks with stuff there. So cool. There are code samples, and all of our slides are shared there. So you can find all kinds of stuff there, and tweet me if you have something specific.
Love it.
And I'm sure you have lots of other good resources we can link to. So.
Yeah, and I'll put a couple links in the show notes, and one of those will probably end up being Laracast, because I know you all love Laracast, as do I, and he covers some OOP stuff. But I will make sure that I link to all of Alena's stuff and all those things, and the show notes will have all that. So go check them out. This is going to be a very, very rich set of show notes this time, so definitely check it out. So the last thing before we go for today is one personal fun thing at the end for everybody, and I have not seen Portlandia, but I have a certain idea in my head when I think of Portland. And right now it is May 8th, and behind you there is sunlight and leaves, and it looks like it's like a beautiful, perfect windy day. And I know that Portland has a little bit of this reputation of being like rainy all the time. So I just want to ask you, as someone who's been there for 6 years, who's not from there, what do you love the most about Portland?
The most one thing,
just one or two or three. Keep it under 4.
The tech community is great. The food scene is great. Being able to get fresh, like I have a friend where I get my eggs and my meat, and just growing vegetables and having a garden and the weather. We have weather. I spent most of my life in Arizona. It was just hot and hotter. And we actually have weather here. Like, it changes. Like, I enjoy that. The change in weather. And it's not so hot. And we don't have a lot of bugs, which is another consideration. Nice. There are not a lot of bugs. So all in all, that's pretty ideal. My husband and I did a lot of searching on where we would like to go and ended up in Portland, and we're very
You're happy with your decision. I love it. Well, Alena, it was an incredible pleasure talking to you. As always, with people who are wonderful, I could have talked for another 3 hours, but let's keep it short for the people. So thank you for your time. As always, all the ways that you can follow her and all these plugs she's already made will be in the show notes. And thank you for joining me. It's been a ton of fun.
Yeah, I had a good time too. It was nice to talk to you.
You as well. All right. See y'all later.